Hey guys, it's Ken. Game programming is hard, and to me it's more difficult than many other programming domains that are common these days, though it's a very close matchup. I think I've nailed down what it is that makes it so difficult, and to fully explain it, we need to cover a wide array of ideas. But to give you a quick summary before we step into those, game programming is hard because there is very little limiting structure to how you can do each individual task, combined with the fact that every added action or behavior to a game has an outrageous number of interactions with it, and even small things can take an extensive amount of time. Note that though occasionally I will put relative information or images on the screen, I don't have as much to show as in other videos, so enjoy a variety of gameplay that may or may not somehow relate to the section I'm talking about. I've been a software developer for about 18 years now. I started in C and have dipped my toes into every major language and quite a lot of minor ones. At the age of 13, I started my own web development service and have made my living off software ever since, from startups to Fortune 500. But let's focus in on web development for a moment. I started learning React in 2020, when everything was half class and half hooks and nobody really knew what the future looked like for reactive SPAs. But within 3 months, I was able to create major applications. And by 6 months, if you asked me to build a 5-page site for your business, I'd have it done in about 3 hours. 5 years later, and if you put a new framework in front of me, I could understand it in a couple hours and build you a professional application in a day, only because reading documentation takes time. This ability to get up and running quick in a new framework comes from 2 things. 1, general programming experience, and 2, the commonalities of all web interaction. And when I say new framework, I don't mean new TypeScript framework. A couple years ago, Elm flashed into my sphere, and within a couple hours, I had a site made that let you build an interactive timeline. You could share it with others, drag and drop and all. I've done the same thing in Rust with Deoxys and Leptos, Go, Scala, yada yada yada. But 18 years of programming experience will make almost any development easier, and I don't discredit that. But the core of what allows me to get up and running so fast is that I don't understand a specific language or framework, I understand the patterns beneath all of these frameworks. That's point 2. Web development is standardized because the web is standardized. There are only so many ways to interact with a web browser, and so before I even look into a language or framework for developing a web application, I already know the underlying logic that will come into play. And if the developers also understand that logic, which, who's writing a web framework and they don't, then the specifics of the language or framework will stand out as a middle layer for that logic. It's a lot like learning an actual language. The first language you learn as a child creates pathways in your brain to connect sounds to ideas, and later to connect symbols to those same ideas. You instill the ideas, you instill the sounds and symbols, then you create the connections for them. When you learn your second language, the ideas get reinforced, but they're not created again. But new sounds and symbols have to get instilled, though the pathways connecting to the ideas are reused. In this context, the rules of the web are the ideas. The pathways are the behaviors that fit into those rules, and the sounds and symbols are the language or framework specifications for triggering those behaviors. So the rules of the web are instilled in me, and have been reinforced over and over and over. Jumping back over to games, we can easily see that Rule 1 applies. I started in Godot about 3 months ago, and a quick 30-second look over a professional script showed me everything I needed to know to write GD script. Variables, functions, classes, iterations, signals. All of this took no time at all for me to be able to jump into writing a game. And if we focus number 1 down into game development experience, I have a bit of a history there too. I started making games around 2010, and you could probably walk to the moon if you printed out all the text used in my Zork clones from those days. I've always been a terrible artist, resigning myself to be a programmer only, and so I never bothered with full games. I made tech demos galore in a looping pattern of play game, see technique, create technique in Unity or Unreal. They never went anywhere, which is sad. I worked a couple small game dev jobs in both Unreal and Unity as an intern, AI programmer, and as a UI developer. These were all on indie games, with indie studios full of scrappy go-getters that wanted to shoot for the moon and yet never got off the ground. Each of these failed early, and though I made a wage as a UI developer, I would have made more working at Starbucks. And a couple years ago, I got tired of it. I started to get tired of games in general, and while I still played a few, I did very little game development, barely followed gaming news, and figured I'd do something else with my life. But then I had some time off work, and I bought a PS5 on sale to fill some time and try out some of the games I'd missed out on. I still barely played anything until one day I was browsing around and decided to try Days Gone, an amazingly immersive game that while not meeting the wild expectations I had in my head, spurred me out of my slumber. It got me thinking about games again. I couldn't pull myself away, and by the end of the game, I could barely focus on it because my brain was so full of ideas. So, moments after the credits rolled, I sat down and started writing a game design document, which ended up being about 400 pages of story, systems, mechanics, balancing tables, style plans. I mean, if you've never written out a GDD, I highly recommend you give it a shot. It's a bit like writing a novel, a spreadsheet, and a software crash log all in one. Side note, the GDD for the game I'm currently working on is only 35 pages, though growing. That's how grand of a design I had. Now, a game like this, with over 150 pages of game system details alone, is impossible for me to create alone. I could work the rest of my life and maybe get it done. It's a AAA game in all manners of the phrase, and I don't say that to brag about it. It's not like it's the greatest game ever. I say that because the amount of work required would need hundreds of people in probably at least 5 years. There is no level of game development experience and no amount of autism that could lead any individual to finish a game like this alone. Yet it's my dream to make it. And if I ever get the chance, I do hope you'll play it. But this is about programming, so let's narrow in on various systems and see what's involved in them. 3D navigation for AIs is a whole lot of work. There is an excellent cover by Alan Chu of the work he did on Uncharted 4. And two of the items he covers is the post system and the buddy follow system. The post system is now, and was starting to be then, a fairly common 3D AI system, where designers generate posts around a terrain, assign them certain weights depending on the AI agent's state, and during gameplay, the agent determines the best post to take position at. But take a look at this image Alan shared. That is hundreds of posts, just visible from that single shot. That will occupy maybe 10 minutes of the player's experience. Alan says the posts are initially generated by a tool, and then the designers tweak their positions and stats. Now think about how long that tool took to write, test, and get correct over all the terrains Uncharted 4 includes. Then think about the amount of time in every set piece the designers spent tweaking the posts, the amount the play testers spent ensuring the agents took reasonable paths, then cycle back through that loop who knows how many fucking times. And this is just for a post system. This is days worth of work, even if you only count the programmers on the tool and the decision algorithm. He then describes the follow system, which is separate from the post system, that generates positions around the player using various heuristics for the AI to move to as they're following the player, so that they don't just lag behind, they actually look a little proactive. That's another day of programming at minimum. And that's assuming you're already familiar with the vector and quaternion math required. Also, you have the follower movement system set up, your designers have already accounted for all of the terrain types, and don't even get me started on doing all of this in a performant way, man. I mean, performance is a fucking hassle. There are two systems for 3D agent navigation, and at minimum, you've already racked up at least a week. If we're being realistic, this is closer to a month, if not more. Every game needs a menu, and every menu needs buttons, and every button has to do something. So by default, a menu requires three things: a display, a button, and an action. At minimum, one button needs to change scenes so that you can, leave the menu and play the game. So you have to make the menu scene, and you have to add the button, and you have to make the scene it goes to, and you have to connect the button to the scene change. Now this is pretty easy shit. It might take you like 5 minutes for a basic version. But every game worth anything has an options menu, and that needs buttons, and maybe sliders and toggles, and all of these things need to trigger actions to change the settings, and hopefully save those settings and write to a file, and have a button to leave the settings, and oh my god, we have so many fucking buttons, I can't believe it. That's 10 to 30 minutes at least. Somehow your players have to be able to leave the game, which means we get to assume the game exists in some form and not count that time. So you need some kind of menu that opens in the game, which means at least one more button and an event handler to open the menu. But there's also the options menu, and if you made your options menu a full separate scene, you have to update it to embed in the game. But we won't count that time because I assume you're a smart person. So that's at least another 5 minutes. So assuming you have two buttons on the main menu, an options menu, and an in-game menu for exiting and options, you've spent about half an hour at least. I won't delve into making your menu cool, or making other menus that get used in your game, which you most certainly will have for the majority of games, but think about that amount of time. Half an hour. Instill it in your brain. That's more than an episode of Seinfeld. Think of a simple combat system, the simplest user interaction. It's called a click, and it won't keep too many people engaged, but it fulfills our requirements. It needs a click handler. It needs to make sure the click is targeting the enemy. It requires an enemy to exist. It needs that enemy to take damage. It needs that damage to do something at some point. These are the minimum requirements to say you have a combat system, and we haven't even talked about the enemy dealing damage back. As evidenced in my Editor Basics video, you could set this up pretty damn quick. I would bet you $10 I could do it in 10 minutes, but that's 10 minutes. Half an episode of Seinfeld. And this is barely a combat system, man. You want to do action combat with a melee system supporting dodges, parries, guards, heavy attacks? I mean, calm down, man. You can do it, but I bet it'll take you a day to get all that in at a basic level. And you'll be refining that until the day you ship. Do a quick Google search for me, will you? Google Programming Dark Souls Combat in Unity. You'll likely find a couple Reddit posts asking for exactly that, and you may come across a few tutorial series like this one by Sebastian Graves. It's an excellent series, and if you're still using Unity, I'd highly recommend it. He gets through each topic at an intermediate level about as fast as he can, but take a look at the length of the playlist. 1 day and 20 hours. You can shave a few hours off if you don't care about netcode. But that's a shit ton of Seinfeld you could be watching. Now go look at some of the other tutorials. Look at how they handle movement, rolling, attacking, archery, invincibility frames, collider clipping, stamina. These games have so much in them. Tell me this. Do any two of those tutorials use exactly the same code? Do they even come close to being the same code? I'm willing to bet that once you've gotten past basic movement, they all diverge into their own little way to do everything. And speaking of basic movement, in that tutorial by Sebastian Graves, he refines the movement twice. Let's call all the way back and remember point 2. I can get up and running in a brand new language with a brand new web framework because programming languages and web frameworks are standardized. They make sense. There's very few ways for you to do any specific thing. You can write your implementation, ask your friend to write theirs, and ask Claude to write its own, and they'd come out pretty similar because it's standardized. Game development is not standardized. It has common methodologies, sure, but not standards. The commonly taught standard framework of game development these days is the Entity Component System, ECS, and it's a pretty great system. And for a fun trivia fact, the first game to pioneer the ECS architecture was Thief in 1998. Another reason it's one of the best games ever made, unless you hate ECS, in which case it's still one of the best games ever made. You're just a hater. But ECS isn't actually the most used system, or the most straightforward system, or even standardized in itself. Though pioneered in 1998, it took about 12 years for it to gain popularity, and wasn't considered a regular game engine methodology until the 2010s. Unity and Unreal, the most popular game engines, aren't actually ECS engines. Unity has ECS ideas, but supports these with its own blend of methodology. Unreal is closer to a pure OOP design. Frostbite, an engine known for its complexity to actually use, supposedly is fairly ECS focused, and if you're familiar with BioWare's struggles in switching to Frostbite, I think that was the main cause. But what do I know? Godot, the engine I've grown to love and hate over the last few months, is not an ECS engine. The inspector displays information to you in a way that is fairly familiar to the ECS inclined, but it's really just classic OOP with composition mixed in. From talking with professional game developers, I've found that most in-house engines aren't ECS engines either. In fact, ECS engines, when built in-house, are a bit of a lower AA and higher A cost games only situation. No data to back this up, but please accept it with no proof. If you told 10 people with game programming experience to sit down from scratch and write the same game, you'd end up with 10 wildly different variations. Some of them would model ECS, others might use MVC, some would stick to the classic OOP standard and let the chips fall where they land. And even those that choose the same methodology would implement it differently. But let's break those three down real quick. The Entity Component System architecture uses three core ideas, all of which are defined in its name. An entity is an item in the game space, which stores data about itself, usually just an ID. Within that entity is an associated set of components, substructures of data that define aspects of the entity's existence in the game space. An entity can be associated with as many components as your engine supports, theoretically an infinite amount, and it's these components that actually make your entity a real actor in the game space. This is what we call composition, where an entity is composed of components, but doesn't do much on its own. Composition is an extremely useful software design pattern, and if you've ever used a mix-in, it's the same idea. But these components are worthless without systems, which are a core of the engine, but can also usually be added closer to the entities for more control. And these specifically query entities, which is where the ID of each entity comes in handy, for components the systems are meant to act on. And when the entity has one or more of these components, it, acts upon it. This is how a physics engine knows what to apply physics to, or how a display knows which entities actually have a visible display and need to be drawn on the screen each frame. ECS is a version of data-oriented design, which as an idea stretches back pretty far, but also gained popularity fairly recently. Data-oriented design focuses on, as the name implies, data over objects. It's great for things like parallelization, read speed, and can reduce CPU load by an incredible amount, which is why it was adopted for game consoles around 2010, and as far as I know, it's still being used for them. The Model View Controller Pattern, MVC, will be very familiar to any of you out there that have developed web or desktop applications. Before reactive took off, MVC was king, really, and programming a reactive system is usually just MVC disguised, but I won't start that war right now. Like ECS, its name reveals its design. A model is the data about an item on the screen. The model uses its data to update its view, which is what's shown on the screen. The user interacts with that view, and those interactions are handled by the controller, which affects the model appropriately, which updates the view. This one stretches back to the 70s, and will likely be with us in the GUI world for the rest of time. But in the game world, it's practically non-existent. People use it, don't get me wrong, and if you know any Flash developers, first I'd like to say sorry about ActionScript, but they'll be able to tell you that MVC had a special place in their workflow, not usually as the main driver, but they'll remember where they used it. In terms of professional MVC game engines, I'm willing to bet that basically none exist, especially not today. It's just not an efficient way to develop real games, even if it is fairly intuitive and useful for more basic things like prototyping. The first prototype of the game I'm working on now was an MVC design because it didn't take long to write. Depending on your experience in college or shitty Java tutorials, you'll either love or hate OOP. I'm a functional man myself, and the day they come up with an intuitive game engine in Erlang for the front end is the day I give up OOP completely. But for now, we're stuck with it. Before Thief, and still widely to this day, OOP was the standard of developing games. Its name isn't quite as intuitive as the other two, but it does hit on the focus. Everything in the game is an object, and those objects get called upon by the engine to perform behaviors. And this constant cycle makes a game. Inheritance plays an extreme role in OOP engines, like Godot, where you can clearly trace the inheritance structure of every node in your game and see what behaviors are added at each level of the hierarchy. The common complaint of OOP by those that prefer ECS is that OOP games can be difficult to optimize, and you can refer back to the ECS section to understand why. OOP requires a lot of behaviors to be loaded all the time, take up a bit more memory space, can cause dead pointers, shifts in memory can lead to critical errors, and inheritance can get pretty tricky to track as games grow larger. But an interesting thing to point out is that the same way lots of ECS engines aren't pure ECS, OOP engines don't have to be pure OOP. These are just ideas, and making a product means more than sticking to a set of rules. It means doing what's right to get a good product made. There's a link in the description to a very interesting slideshow by the Frostbite team about refactoring your OOP code to be more data-oriented without adopting an ECS or even a focused data-oriented design. At the beginning of the lack of standardization section, I asked you to look up tutorials and compare their methodologies for doing the same thing. And now we've talked about how game engines can also have different methodologies about doing the same thing. And this is where some people gloss over certain aspects of game engines. I'm sure you've seen those how to pick the right engine videos, and I love watching these because they always focus on the language used or the community support or the functionality they have or lack. Few of them dive into this methodology point, but it definitely makes a difference depending on the individual. I love ECS for what it is, but I've come to love Godot because of how it focuses on OOP and mixes in composition to create a fairly clear code-focused development with a separation of responsibility when you decide it's best to do so. But some people feel best in an ECS environment, and it is one of the most straightforward when combined with a competent interface, and though Unity isn't a pure ECS engine, I think this is why it took such a hold on not only indie devs, but on professionals as well. Back in 2014, when Blizzard announced Hearthstone and revealed it was made in Unity, back when it was even less ECS, I'll admit, I felt a bit confused about this. But when I went into Unity and developed a card game the way I thought Blizzard would develop it, I started to understand why they chose it. Hearthstone has few expensive entities, and each of these entities really only need a couple components at their base state. The core of the game development is on art, loading data into the few entities that exist, and establishing a rule engine for card interaction and game steps. Card behaviors are most certainly designed as components, and designers attach those components as serialized data to the card definitions, creating a method of infinite combinations for card behavior. OOP really doesn't make a lot of sense here, as the inheritance structure would restrict how cards can be designed and what combinations of behaviors could be used without either making a new object, which is not a good idea, or using mix-ins, which would bring them closer to an ECS design without the actual benefits of an ECS engine. But again, this decision didn't come from a standard way of developing card games. It didn't come from a standardized methodology of how systems like this should be developed. It came from breaking down their game and finding the requirements for how the game should work, then taking those requirements and finding the game engine that best fits their requirements. Blizzard could have used an OOP structure to make Hearthstone, and with their level of skill back in 2014, they probably would have still delivered a high-quality game, but they chose to use an ECS system because of their own requirements. Balatro was made in Love 2D, which usually implies an OOP approach, though you can implement your own ECS system inside it should you prefer. Would Balatro have benefited from using Unity or another ECS-ish engine? Maybe? I heavily suspect Balatro is fairly data-oriented, but it didn't have to use an ECS engine or even be data-oriented. No game has to be developed with any particular architecture design. And this is exactly what I mean. Back to those original 2 points on why I can jump into any web framework easily. Programming experience and standardization. Games have no standardization. Simple things have limited ways they can be done solely because they're simple, but even those don't have standardization. Implementing simple 2D movement means you have to decide how and where you're going to accept input, in unhandled input or maybe in process. And are you going to use the input vector or check each input separately? Even WASD movement isn't really an explicit standard, it's just what we've come to expect in games. And none of these decisions are the wrong way to do these things. They're just different ways of doing a similar thing that root down to the same outcome. They're not the sounds and symbols that link up the ideas, they're the actual behaviors. Game programming, no matter what you pick to do it with, asks you to learn a wide range of behaviors that link up to ideas and give you an explicit symbol for each of these behaviors. And that's not how the brain works. The brain expects one or more symbols for a specific link to an idea, but game programming is many symbols, each with their own link to the same idea, and sometimes these aren't even explicit symbols. If you try to map this out in your brain for everything you can do to make your game, you would go insane. But let's leave standardization behind and talk about what actually matters to you, the vibe coding solo developer with hopes and dreams. And let's build an example here. You're making a 2D platformer with melee and ranged combat. You get your movement working, you add a collider that swings around for the sword, and you create a projectile for ranged attacks. So the player, by pressing the attack button, triggers an event handler, a state change, an animation switch, a collider transform, collision checks, a final collider transform, another state change, another animation switch, and maybe some timers. If the player actually hits an enemy, that bumps up to even more interactions. If you're not familiar with interaction complexity, it's the measure of how many other systems an action interacts with. So at a minimum, pressing the attack button interacts with 4 systems: the event bus, the state machine, the animation player, and the collider. When the ranged attack button is pressed, you interact with the event bus, the animation player, the scene tree, the state machine, and the projectile itself. These are fairly simple game mechanics, and yet when you break down their interaction complexities in their simplest form, you're into the O of 4n and O of 5n territory, And we haven't even brought in enemies or friendly NPCs or even making the combat system more engaging. There's an excellent article IGN did a few years back where they interviewed various AAA devs about how simple game mechanics can be extraordinarily complex to get right. And I highly suggest you read it, so there's a link in the description. But the big thing highlighted there is doors. I love doors, and I would never make a game without doors if I could fit them in somewhere. But they are difficult and annoying. Here's the data section of the door script I'm using in my current game. It can be locked or unlocked, tracks entities trying to exit through it, changes sprites when it needs to open and close, and has a dialogue script for when the player tries to open it while it's locked. The entire script comes up to about 150 lines of code, and I do incremental programming, so when I get to the point I have planned where there's more behavior for these doors, it will likely go up to about 250. When using this door in the game, I have to keep it in mind when scripting NPCs, because sometimes NPCs need to leave a room and lock the door afterward, or unlock a door when they enter a scene so that the correct animations play as they pass through it. I need the collision to detect the proper entities so that I can have scenes where the door is physically blocked, but the door isn't triggering its collision code every frame. This door took me close to an hour, and I'll have to refine it as it gets used more and more and as I add more behavior. When I mentioned that the Uncharted 4 post system and follow behavior probably took about a month to make, I wasn't trying to scare you. When I talked about how a simple menu implies and requires more menus, and an action combat system might take you months to get right, I was just laying out the facts of game development. Games are software with an extremely high interaction complexity. Every developer knows this. Adding one new system might make you have to refine every other system to account for it. And while scope creep is dangerous in any software development, in games especially, it can mean doubling your development time. When I decided to do the 8-hour Gyromancer stream, I knew everything I've told you today. I knew how complicated simple things can be in games, and in that video I said, I like a challenge. And I do. If you've catched my streams, you've probably seen me give up toward the end because something simple like dropping an obstacle into the navigation region can cause a bug that takes 2 hours to fix and I still don't fix it. But when that happens, I always wake up the next morning and get back to work. I fix the bug, take a deep breath, and head into the next task. And I do this day after day after day because I love games. And I find that games are one of the most interactive, accessible, and unlimited fields of creativity. I can't paint, I can't sculpt, I can't sing very well. I can write, and I can play a guitar, and I can write code. When I get down into something that I want to have a high level of expression that I am good at, and that I have already gotten to the point where to catch up to the amount of hours I've spent getting good at it would take you years. I like games, and it's what makes me like them that also makes them so difficult to make. A world of unlimited creativity means that anything can be done anyway. And that is insane. It's the blank paper idea, right? It is hard to sit down to a piece of blank paper and start writing. But if there is a single word on that blank paper, suddenly it is easier to write. The idea that as you limit yourself, your creativity grows. There's no limitation innately in game development. There is none. And that's why it's an art. Because you have to take this ultimate unlimited section of possibilities and force yourself into a boundary so that you can start generating ideas. That's why we have genres. That's why we have common action sets. That's why we have so many things. Because if we didn't, we would all go insane. And so I love making games, but it is so hard. Programming games is so hard. And yet, when it feels good, it is so easy. It is so simple. Everything is just smooth. You slide right into it. And I wouldn't trade that for the world, you know? But should there be more standardization in how things are done? Should game programming be more like the web, where it makes sense that there are only a couple ways to do something. And so anyone can learn the root ideas and jump in. Should we limit the number of symbols in our game engines so that simple things have to be done simple ways? I don't know. I don't think we have to, but maybe. I I think games are going to keep being made however the developers want to make them. And every single game developer is going to make a mistake in how they decide to make their games. And whether it's the very next day or 3 years down the road, you're going to kick yourself in the foot for a decision you made. Because none of us are perfect. And without a strict standardization, you will always make a bad decision eventually. But with strict standardization, could we break out into new genres and new ideas and new methodologies if we trap ourselves in a box of what we already know? I don't think so. And so I think the fact of the matter is that game programming has to be hard. It has to be. There is no world where we can make great games and it not be difficult. And not even in a sense that everything worth doing is hard. In a sense that the greatest games are made by doing something that has never been done before. And standardization will not allow you to do something that has never been done before. So I hope you've taken something away from this. And if you haven't, let me know. Because this was just a mess. And I hate game engines. I really do. And yet I love them. And I'm immediately going to go back into Godot and bash my head on the keyboard for this bug. And tomorrow morning, I'll do it again. Bye.